Okay, now for the assignment. Now that you know how to do the square, to square those and understand all that business, that's what you're going to apply it here for solving these problems, doing these problems, actually proving if these sides of these triangles can be the sides of a right triangle. So here we go. Again, copy these down. This is again chapter 9.1. Remember, you can always look at your book. You can always look at your book and also look at the examples in the notes there. And there's you can see your book online as well. I put a how-to video right in the yellow folder on Schoology, so you know how to find your book, how to get to your book. Okay, so this is part 1, Pythagorean theorem. Pythagorean theorem. That's what it's about. But we're going to do kind of something easy first. This is what the Pythagorean theorem is. The Pythagorean theorem has to do with the right triangle. In a right triangle, when they talk about this word right, and I'm sure some of you know this already, and the bad thing about, I noticed the worksheet, it just shows a triangle like this. When you hear this word right, it means that what? What's the thing that makes it right? Well, it has a 90-degree angle, and usually this is the symbol for 90 degrees. Right? It has a 90-degree angle. All you have to do is have this symbol. And I noticed that on the worksheet, the triangles don't have that symbol. Well, I kind of think I know why. Maybe because for the assignment you have to prove that it is a right triangle, so they're not really putting that angle yet. But we're gonna check if this is a right triangle and that makes a 90-degree angle. Now, the Pythagorean theorem is actually this: a squared plus b squared, and I hope you've heard this before. You should have. A squared plus b squared equals c squared. Now, what does that mean? Well, here, the a and the b and the c are the sides. And the most important one is that one. You better watch out for c. The other two you can put however you want, but c has to be the hypotenuse side. This diagonal side, this one is always your c side. Okay, and then a and b, it doesn't matter, right? Because you're adding them anyways. It doesn't matter which one's a and b, but this one has to be c. Don't ever put this one wrong. That's where students mess up. So here's a and here's b. So what's true about every and any right triangle? That if you do this, and I get this number and I square it, and then I get this number and I square it, and I add those two, that should be the same as this number when I square it. So let's check. Now in the notes it's going to say state, here's the directions, right? State if each triangle is a right triangle. You're not finding any missing sides yet or anything. We're going to do that later. State if each triangle is a right triangle. You have to determine, when it says right here state, that means to determine if it's a right triangle. And they're going to give you the 3 sides. Now, another way of saying it, and this is not the way they said it here, is I've seen this in other books or in other worksheets. It says this: could, and this is kind of what this is really saying, could these be the sides of a what? Could these be the sides of a right triangle? So you don't have to find any sides. They're going to be given to you, okay? But what's the key thing? What's the key thing? that it's a right triangle. Remember, when it's right, it has to have a 90 degree. Could these be the sides of a right triangle? Why did I put triangles? No, just triangle. So here's an example real quick. Number one. Let's say I have a triangle like this, and they're gonna change the orientation, but again, we're gonna assume that it is. I'm gonna assume that it's 90 degrees, and I think that's why they didn't put the 90 degree symbol on the corner. But here's a very popular one. 3, 4, 5. Could these be the sides? They're gonna give you the sides. They're not asking you to find anything. You have to determine if these could be the sides of a triangle. Well, in order for you to check, what has to be always true? The Pythagorean theorem. The Pythagorean theorem has to check out, and this is the little formula, this little equation, the theorem you got to check. We got to check that this holds true. Is it true that a squared plus b squared gives me c squared? Right, that's the Pythagorean theorem. Remember, a squared plus b squared equals c squared. This is what you got to do to check. You got to check and see that this gives me an equal statement. I got to add these, and whatever number this is, I got to add these, right? Add these. And if it gives me the same as this one squared, it's a right triangle. If I add these and it gives me like 100, and then I do this, and this number is like any other number, like 90, and it's not 100, then it means it's not a right triangle. So you have to verify, and you don't just tell me yes or no. You got to show the work, right? So what did I do? What do I do? How do I start? Label your sides. Remember, the most important one is this one. This diagonal side is your C. So actually, I'm only going to label that one because that's the most important one. I don't care which one is A or B here, but if you ever put this one C or this one C, you're never going to get this right. Okay, so all you got to do is what? You know what? I'll label them anyway. I'll just call this one A and I'll call this one B. But for sure, this one's C. Okay, so what do I got to do here? I got to do A squared. That's 4 squared plus, right? A is 4. And B is what? Plus. And actually, I did something that I tell students not to do. I'm sorry. I always put the C first. I should have put the C one first. That way I won't mess it up over here. I should have put the 5 first. I should have put the 5 first, make sure I get this one right, and then do the other ones. Okay, all you got to do is substitute the right numbers into this pretty simple equation, yes? I know what 4 squared is. That's 16 plus, I know what's 3 squared. 3 squared is 9. Is that equal to, what is 25? So you're not solving anything. You're just checking if you get this equality, right? That's what equals means. Is it true that when I add these two numbers, it gives me this? Yeah. This one is good. What does it mean when you get the equals? That means that yes. The answer is yes. This is correct for a right triangle. These sides would be correct. Okay? And that's all you're checking. All right, let's try another one here. Real quick, number 2. What if, and again, they'll change the orientation of the triangle, right? They'll probably put it like this. But which one do you think is the C side, right? You're going to assume this is the right angle here, right? The corner one, but here's your C side. So what if I put, some students think that just because 3, 4, 5 works, maybe let's check 4, 5, 6. You think that's going to be true? Just because it's 3, 4, 5, you think, and by the way, this hypotenuse side is always the longer side. So let's say that, let's try and check 4, 5, 6. Let's see if that works. Could these be the sides of a right triangle? Or the directions say, state of each triangle is a right triangle. Well, we have to verify using the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals what? C squared. But remember, which one's your C side? You gotta always put that one first. Which one's your C side? This is a 6, by the way. The hypotenuse, this is the C side. So then I'll just make this one like A and B. Doesn't matter which. I don't care about A and B. C is the most important. Put that one first. See, put that one first. That's 6 squared. C, 6 squared. And then A is 5 squared. So you just got to check this. That's all you're checking. That this gives me equality. B is 4, so I got to square it. Is it true? Is it true? Let's see. 25, right? 5 squared is 25 plus 4 squared is 16. Is that going to give me 6 squared is 36? Oh, is that going to give you that? Well, let's see. 25. Here's the equal sign. Don't move anything. 25 plus 16 gives me 41. And this side gives you what? Well, this side's just 36. Is 41 the same as 36? It didn't give you the equals. They're not equal. So what does that tell you? No, they're not equal. Sorry, they're not equal. That tells you that nope. I mean, these could be the sides of a triangle, but this is not the sides for a right triangle. You can have a triangle with a 4, 5, or 6, but it won't be a right triangle. It won't have 90 degrees. So all you're checking is this. If you do it and you get an equal sign, yes, this would be the sides of a right triangle. If you check it and it doesn't, then you're going to say no. These cannot. This is not a right triangle. Not a right triangle. It's a triangle. You can have a triangle 4, 5, 6, but it's not a right triangle. Okay. Check the last video. That one's gonna have the problems that have like the square roots and these difficult ones, okay?